Alright, with number 3, this time we get to use synthetic division, which is a lot nicer. And so let's talk about that. The k equals 3. That's the number that we're using to divide, and we only focus on the coefficients. So I have 3, which is what I'm going to call my box number. It goes in this little half box. And then you have to look at all your terms. So this polynomial is 5x to the 4th minus 19x cubed minus 5x squared plus 64x minus 39. Okay, so we are not missing any terms. This one allows us to only focus on the coefficients. So I'm only going to write down 5 from the first term, and then a negative 19 from the second term, minus 5 for the next term, plus, well, we don't have to write plus, just write a 64 as positive, and then a negative 39 for the last term. Alright, notice your polynomial starts with the 4th degree. We're dividing out one degree. That's always the case. Dividing out one number at a time. So instead of starting with the x to the 4th, when we divide this, we're going to start out with x to the 3rd, and then I'll have an x squared, and then x, and then a constant. So depending on what these numbers give me, those are going to be my coefficients plus my constant at the end. Okay, so you always bring your first term straight down. So 5. Then we multiply 3 times 5, write the result up here. So come below the line, you multiply, write the result up here. So we get 15. Add these or subtract them, and you get a negative 4. And then you repeat the process. 3 times negative 4 gives you a negative 12. Combine these, we get a negative 17. 3 times negative 17 will give us 51, negative 51. Combine these, and we get 13. And then 3 times 13 gives us a positive 39. Combine these, get 0. So the last number is your remainder. We don't have a remainder, great. So these are going to be my coefficients that I was talking about. So this first one is 5x cubed. Then it's going to be a minus 4x squared minus 17x, and that's positive, so we'll say plus 13. So here is the resulting polynomial. A lot nicer when you can do synthetic division, and when you don't have a remainder, then that's it. So this question is saying, is k a 0? The way you know it's a 0 is if you do this process and your remainder is 0. It comes out equal. So yes, k is a 0.